What's going on, everybody? It's Mr. Diamond, and we're going to be working out an example problem for boiling point elevation and freezing point depression. And I've got a couple of important pieces of information up here. First of all, I have a simplified version of the temperature change equation. The way I usually tried to remember it when I was first learning this stuff was that delta T equals K me, because I think it kind of rhymes. Delta T equals K me, K M I. Again, K is a constant based on the freezing or the boiling point. M is based on the molality. And then I is Van't Hoff factor. And then I've got my KB and my KF for water over here. This we aren't going to need. I just wrote this down here for one of the later problems, so we don't need that. I did forget, though, we need molality, and that is moles of solute over kilograms of solvent. Okay, and our problem here is a solution is made when 11 grams of sodium chloride is dissolved in water to make 146 grams of solution. What is the boiling point and freezing point of this water? So, first thing that we're going to want to do, we know we're going to need molality because we're going to be trying to plug into this equation. So molality equals moles of NaCl, because that's sodium chloride, over kilograms of water. We know NaCl is the solute because it's what's being dissolved. We know water is the solvent because there's going to be more of it. So first we need to figure out how many moles of NaCl do we have. Well, we know we're starting with 11 grams, so that's 11.0 grams of NaCl. And we're going to have to use our skills with our dimensional analysis. I was looking around for a periodic table, and I don't have one close. So in A, it looks like it's 22.99. I don't want to do this with an incorrect number, so we're just going to Google it while we're here. NaCl mass. Mass of sodium chloride is 58.44. according to the Google, and that is grams per 1 mole of NaCl. Our grams of NaCl will cancel. We'll be left with moles of NaCl, which is what we want. Remember, you've got to divide by that number because we want it to be grams over moles normally. We have to flip it to get it to work that way. And then my calculator is right here. So we can plug that in. We'll get 11 over 58.44. That'll give us 0.1882272, blah, blah, blah. Or if we round it, which we're not going to for plugging into our equation purposes, we round it, we would get 0.188 because 3 sig figs is our smallest in our answer. And that's moles of NaCl. But that's not a final answer, so I'm not going to round it there. I'm going to use this number for plugging it in. Next, we need kilograms of water. Well, we know we started with we ended with 146 grams, but we got there by adding 11 grams of NaCl. So if we subtract that, we get 135 grams that isn't NaCl, so that must be our grams of H2O, which is the same thing as 0.135 kilograms of H2O. So now we have enough information to solve for molality. Molality is our moles. So that's our, I'm going to write the rounded number, but I'm going to use the full number. Moles of NaCl inside 0.135 kilograms of water. So again, using the full number, divide that by 0.135. And I get 1.394275, blah, blah, blah. Or when we round it, 1.39 molal, which is just a little m. Okay, we have moles. We have K that we'll need for each of these because it's in water, so we know these two constants. So now we just need I. I for NaCl is going to be equal to, well, it's an ionic compound because it starts with Na. There's 2 pieces, so I equals 2. Now we have enough information. We can do our delta T. So first, we're going to do delta TB. We're going to do change in boiling. KB is 0.51 times our molality, so that's our 1.39 molal. I am going to use the rounded one on this one just because I want to keep it consistent in my calculator, and I won't be able to do both of them with the unrounded one. And then the Van Hoff factor is 2. So we'll plug that in, 0.51 times 1.39 times 2. We get a delta TB of 1.4178, which we will round to 3 sig figs, 1.42. Now this is our change in boiling point. The question asks what is the boiling point. So you also have to know that normal boiling point is 100. So 100 degrees Celsius plus 1.42 degrees Celsius will give us our new boiling point of 101.42 degrees Celsius. Now we're going to do the same thing, but we're going to do delta T F, delta T freezing. Now it's going to be negative 1.86. Then it's going to be our 1.39 and our 2. We'll plug that in. I'm not going to type in the negative, so I'm just going to do 1.86 times 1.39 times 2. I'll get 5.1708, which is approximately 5.17. But it's negative because this was a negative. I just didn't plug that in there. So now we're going to have to do, well, what is our freezing point? Our freezing point is 0 degrees Celsius minus 5.1708 will give us negative 5.17 degrees Celsius. So in this case, adding a whole bunch of salt, relatively speaking to the amount, 11 grams to 135 grams of water. That's 1/10 the weight of the water in salt. We only changed the boiling point by about 1 degree and the freezing point by about 5 degrees. All right. That is our example for boiling point elevation or freezing point depression. If you've got any questions, please shoot me an email. Otherwise, this is Mr. Diamond signing off. Have a great rest of your day, everybody.